Good day, students. Welcome to part one of the Nevada High School Proficiency exam. In this installment, we're going to be going over questions 1 to 5. You can gain access to this document that I'm working on online. Just by clicking on this link, you should be able to gain access to this document so you can work along with me. All right. So let's take a look at question number 1. So for number 1, we are to simplify the expression the square root of 3 square plus 3 square. So one mistake that someone might make taking a look at this expression, so let's call this wrong approach. Wrong approach. Um, since these are square root of squares, one might assume that, oh, wait a minute, let me just take the square root of the two numbers, or I can take the square root of 9 plus 9 and write this as the square root of 9 plus the square root of 9 equals 3 plus 3, and you get 6, and you fall for this distractor C, which is a wrong option. Okay, so this is a wrong way of doing it. What's wrong with this approach? Well, the idea is that you have to simplify the radicand completely first before you can take the square root. Thinking about order of operations, imagine that there is a parenthesis around around the terms in the radical that must be addressed first before you can take the square root. Okay, so we have the square root of 3 square plus 3 square. This sum and the squares have to be addressed first before you can take the square root. Okay, the square root you can't take the square root before you do the sum. That's violating the order of operations since the sum is inside the parentheses. Okay, so what we're doing is basically following, please excuse my dear Aunt Sally, basic order of operations. All right, so let's simplify this quantity under the radical symbol completely first before we take the square root, as opposed to doing it partially and then rooting it and then doing the sum. Okay, so if we do the exponents first, following order of operations, we square these, we have the square root of 9 plus 9. So this was okay up until here. Now what do we do next? You have to add these two numbers first before you take the square root. Don't root them independently, that's inaccurate. So you're going to have the square root of 18. Okay, now you notice that this has to be simplified further. So let's go ahead and simplify this. Now what we're going to do is decompose this number into its prime factors, all right? And then whichever prime factor occurs in pairs, those will come out of the square root, since the square root of two identical factors is one of them, okay? So let's break this down. The first prime number that goes into 18 is 2. So 2 goes into 18 9 times. And then the next prime that goes into 9 is 3. 3 goes into 9 3 times, okay? So you notice that these two factors repeat. So these two can be viewed as 3 times 3, and the square root of 3 times 3 is just 3. So these two come out as 3, okay? So how do you read this simplification process? Whatever repeats comes out of the square root as 1, because the square root of 3 times 3 is just 3. This 2 stays behind because it's just a factor by itself, all right? This should not be interpreted as 3 root 2, that's inaccurate. As 2 root 3, that's wrong. So the correct answer is 3 root 2. And we can see that option B is your correct answer, okay? Now let's take a look at question number 2. It says, which equation illustrates the commutative property of addition? Now, if we take a look at options A, B, C, and D, these are all properties of addition. So let's go ahead and identify what these properties are, and then we'll see which one is commutative. All right? Now, the word commutative, if we think about commute, what does the word commute mean? Commute means to move, right? To travel. You're transporting yourself from one place to another. So there has to be a change in position, okay, or placement. So that's exactly what the commutative property is. So let's go ahead and write down the properties of addition on the side here. So properties of addition. So A plus B equals equals b plus a. This one is a commutative property. It's commutative because the order of addition is being switched around. So a plus b and b plus a is commuted, got commuted to the position of b, and b commutes to the position of a. So we have the switch in order of addition. So that's the commutative property. You also have a plus 0 equals a. This is known as the identity property of addition. You also have a plus b plus c equals a plus b plus c. This is known as the associative. Associative basically means that if you change the order of grouping of your addends, it doesn't change the sum, okay? And then the last one is a times b plus c is equal to ab plus ac, and this is known as the distributive property. Distributive. What's happening here is that this a is getting distributed. So let's see if we can use this list of properties we have here to answer this question. So let's look at option A. You notice that 4 plus x comes first here, plus 3x comes second, and in this side, 4 plus x commutes to the position of 3 plus x, and 3 plus x commutes to the position of 4 plus x. So there's a switch in order of the addends here, so this is the what? This is the commutative property. Commutative. All right, option B, you notice 3x times 4 plus x plus 0 is equal to 3x plus 4 plus x. Basically, if you add any number to 0, you end up with the identical number that you're adding to 0. So that's the identity property. Identity. And let's look at this one right here. 4 plus x plus 3x. It's very similar to this, but what's happening here is that we have a change in the groupings. The first two terms were grouped here. Here, the last two terms were grouped. Nothing got moved to the other position. Okay, there was no movement here. All that happened is the grouping or association. So this one right here is the associative property. Okay, associative property. And then lastly, what's happening here in this last equation in option D is the distribution of this term right here to both terms inside the parentheses. So whenever you distribute, this is known as the distributive property being illustrated here, distributive. So the question is asking which is the commutative property, the one that involves the switch of the order of terms that have been added, is option letter A, okay? So you're supposed to basically have all these properties of addition memorized before the exam in order for you to be able to do well here. And now one thing I want you to notice is that all these properties also apply to multiplication, okay? All right, now let's move on to question number 3. All right, so number 3 involves transforming a data in a paragraph form into a matrix form. So let's read the question. It says, Al, Jim, and Lisa each tutor individual students and small groups of students. So 2 categories, individual and small groups. The list below shows the information about the number of individual students and the number of small groups. Al, Jim, and Lisa each tutored this week. So Al tutored 3 individual, 2 small. Jim tutored 5 individual, 1 small, and Lisa tutored 4 individual and 2 small groups. So it says which matrix shows the number of individual students and the number of small group students that Al, Jim, and Lisa tutored this week. So we have 4 options here. Now one thing you want to notice is what's different in all these options and what's similar. We notice that individual students and small group students, the criteria for the rows are identical in all of them, so we don't have to bother with that. The column assignments, Al, Jim, Lisa, Al, Jim, Lisa, Al, Jim, Lisa, Al, Jim, Lisa. The criteria for the rows are identical, so that's not different. So what's different in these four matrix arrangements are the elements of the matrix. They all switched around. So which one is correct? Well, we'll go ahead and group these tutoring groups. It will be easy for us to determine which one is easy, which one is correct. Okay. So for Al, what was the story with Al? Al had 3 individual and 2 small. So we can write it as 3, comma, oh, sorry about that. 3 and 2. 3, 2. So that's for Al. So Al's column is going to have 3, 2. How about Jim? Jim was 5 individual, 1 small. So it's going to be 5 and 1. How about Lisa? Lisa had 4 individual and 2 small. All right, so let's look at all these options. Which one has 3, 2 as a column for Al? Option B and D. So we have to take out A and C. Those are inaccurate for Al. Now, what do we do next? One of these two is correct. So how do we figure it out? Well, we have to go to Jim. Jim is 5, 1. That should be the order. 5 for the individual and 1 for the small group. What do we have here? 5, 1. Good. How about here? 5, 1. Still the same, so we don't know which one is the wrong one and which one is the right one yet. So the column that's going to determine what the correct answer is the Lisa column. All right, so let's take a look at all the Lisa columns in the 2 options. Which one has 4, 2 as the order of elements? So this has 2, 4, and this has 4, 2. So option B is wrong, and option D is correct. Okay, this is wrong because this matrix is telling us that Lisa tutored 2 individual, and that's inaccurate. It tells us Lisa tutored 4 individual and 2 small. Okay, so this is the correct option letter D. All right, let's take a look at question number 4. It says Lori has 3 shirts, 2 pairs of pants, and 2 pairs of socks to use to create an outfit. An outfit consists of 1 shirt, 1 pair of pants, and 1 pair of socks. What is the greatest number of different outfits Lori can create? I'm going to solve this problem for you in 2 different ways. Method 1 is just basically the use of counting principle. We have 3 spots that make up a garment here. So the first spot is shirt. The second is pants. And the third is socks. All right. So how many shirts are there? 3. How many pants? Pairs of pants? 2. How many socks? 2. So in order to make one complete one outfit has shirt and pants and socks. One of each. Okay, so 1 shirt, 1 pair of pants, and 1 socks. So what operation are we going to use here? When you're using working with statistics and the counting principle, anytime you see and is basically telling you to multiply. Okay, so and is a product. So in order to find out the different combinations of outfit with these items, you're going to simply multiply the different number of each category. So you have 3 and, that means it times 2 and 2 socks. Okay, so the total number you're going to have is simply going to be 3 times 2 times 2. All right, so if you do that, you have 3 times 2, 6, 6 times 2, 12. So you're going to have 12 unique outfits with these options right here. Okay, so this is method number 1, basically using the counting principle. Method 2 is much more visual, probably might help you understand what's going on with this process right here. So method 2, we're going to use a tree, okay? We use a tree method to count it. Now method 2 is limited to problems that the answer is not too big, but if the problem involves big numbers, it's impossible to use method 2. So method 2 does have its limitations, even though it's very visual. All right, so this is our start right here. First thing I'm going to take a look at is shirts, right? Yeah, let's take a look at shirts first. How many kinds of shirts are there? There are 3 kinds of shirts. Okay, so let's represent them with dots. 1, 2, 3. So there are 3 different kinds of shirts. So you can either go shirt 1, shirt 2, or shirt 3. Okay, now after selecting your shirts out of these 3, the next choice to make are your pants. Right? So for every shirt you pick, you have a choice of 2 different pants, right? So let's use the pants. So for pants, you can either go pants 1 or pants 2. If you selected shirt 1, you can go, if you selected shirt 2, you can either go pant 1 or pant 2. If you selected shirt 3, you can go pant 1 or pant number 2. All right, so let me put numbers here to help you visualize what's going on. So shirt, you have 1, shirt 2, shirt 3, 3 different kinds of shirts, okay? And then for pants, you have only 2 kinds of pants, right? So let's put the pants in, let's make it green. So pants, you have 2 kinds of pants. So if you selected shirt 1 first, you can pick pant 1 or pant 2, right? 1 or 2. If you selected shirt 2, you can also pick pant 1 or 2. If you selected shirt 3, you can pick pant 1 or 2. Okay? So if you selected these shirts and pants, now you have 1, 2, 3, 4, 5, 6. But that's not all. You also have 2 unique kinds of socks to select with each combination. All right? So our last leg of our tree is going to be the socks selection area. Okay, so for this route, you have 2 choices of socks. And then for this route, you have another 2 choices of socks, socks 1 or socks 2. And then for this one, you have socks 1 or socks 2. For this route, you have socks 1 or socks 2. And then for this route, you have socks 1 or socks 2. And then for this route, you have socks 1 or socks 2. Okay, so these are your different socks options you have. All right, so you can socks 1 or 2, socks 1 or 2, or socks 1 here or 2, or you can have socks 1 or 2. You can have socks 1 or 2, and then here you can have socks 1 or 2, and then lastly you can have socks 1 or 2. All right, so these are the different unique outfits you can have. Let's count how many dots we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So you have 12 different outfits. That's the maximum number of unique outfits you can have. So 12 different outfits. So you can see that using the second method, although it's visually appealing, but let's say we're dealing with 100 shirts. How can we make 100 arrows? It will be too much, right? So if we're dealing with big numbers, this is the best method to use. Just simply multiply the different numbers of unique items, and then that will give you the correct answer. All right? So that's that. Now let's take a look at the last number. So for question number 5, we're given a right triangle. WR is 3 meters. And RT is 8 meters. We have to find the length of TW. All right, so what formula are we going to use for this problem? You're going to be provided with some formulas on the day of the test. Let's take a look at them real quick. All right, so these are the formulas you'll be provided with on the day of the test. And you notice that all 3 groups of formulas involve right triangles. So which of them is applicable to the problem under consideration? Which is more applicable to this situation right here? So notice that we're given only two sides and we have to find the third side. You can think about this as an SSS problem. It involves two sides and having to find the third side. So let's look at this problem. Special triangles. Let's see. Special triangles involves being provided with with three angles, either 45, 45, 90 or 30, 60, 90. Is that the case here? The answer is no. You do not know the measure of these angles, so we cannot use we cannot use any of the special triangle formulas here because we do not have the angles. How about trig ratio? So katoa, sine, cosine, tangent. Can we use it here? The answer is no, because this involves an angle, finding an angle or using an angle on the side to find another side. But in the problem we are dealing with, we do not have any angle, so there's no way that we can use SOHCAHTOA here. So what must we resort to? The only option that we have is the Pythagorean Theorem. Okay, because it is the only problem that involves three sides, side, side, side. So we're going to have to use the Pythagorean Theorem here. Okay, so let's go back to this problem. The Pythagorean Theorem that we just looked at tells us that a squared plus b squared equals c squared. The sum of the squares of the legs equals the square of the hypotenuse. So in this problem, the hypotenuse is always the side opposite the biggest angle, 90 degrees. Okay, do not forget that. C is always opposite 90 degrees. Now, where's A and B? It doesn't really matter what you call A or B, okay? They are known as the legs. It doesn't really matter how you name it. So let me call the shorter leg A. So this one is A, and let's call this B. So let's apply the Pythagorean theorem to this triangle. If we apply the Pythagorean theorem to this triangle, we're going to have a squared becomes 3 squared plus b squared still remains b squared since we do not know the measure of angle of side B. And then c squared becomes 8 squared since c is 8. So what are we looking for here? We're looking for side B. Okay? So let's simplify this equation. 3 squared is 9 plus b squared equals 64. To get b by itself is a two-step algebraic process. We're going to subtract 9 from both sides and take the square root, okay? Let's go ahead and do that. Subtract 9, subtract 9. We have b squared is equal to 54. I'm sorry, 55. Uh-oh. What's this? All right, sorry about that. So b squared is equal to 55. And then to finish this off, we'll take the square root of both sides, square root of b squared, square root of 55, and then we have b equals the square root of 55, and our answer is option letter C. Okay? So that's that. Thank you so much for taking the time to watch this presentation. Feel free to subscribe to my channel for updates to other cool clips such as this. And please post a comment to let me know what you think about this presentation. More clips can be found on math.serve.com. Thanks again for watching and have a wonderful day.